October 2022, NPM registry API. Is that convenient to use it? Certainly. When you're setting HTTP requests as an unauthenticated user to it, it obviously returns you 404 response, and that's cool. But it turned out back in the day, discovered by Aqua, also this response contain some additional information like the time in milliseconds that takes the server to process your requests. So it turned out side channel attack was possible in this case, so you can analyze the different times, and then hacker would create, for example, as a type squat in the repo, which is similar to your repo, and take it away, so that users can download malicious content. That is, guys, your open source, not someone else's. June 2023, Bingham is a popular arithmetic library for Node.js. It is also used in OpenSSL in some kind. Until the version 0.13, it relied on the Amazon S3 bucket to allow users to download some pre-built binaries during the installation as an add-ons. Reported by checkmarks, it turned out that malicious actors would poison and take over these Amazon S3 buckets, so that when you download even the legitimate library, it turns out InfoStealer is incorporated in it, and it could send your IP, credentials, user environments, whatever, in the local machine back to the command and control server. It is your open source, not someone else's. Welcome, and thank you for surviving the lunch. My name is Roman, and I'm from Intel, and I hope we all had a good time. Have a look at your badge, and if you can see this, all the corners cut off, you definitely had a good time yesterday. So, a little disclaimer as usual, like legal stuff. All opinions are solely mine, not necessarily reflect the official views or opinions of my employer. But you might ask what I'm doing here as an Intel, as a chip maker. I'm not giving away chips, unfortunately, sorry for that. Nor I'm not giving some confidential information, but we're going to speak about the useful tools and approach that we found to be useful when tackling open source. Why Intel and open source? You may be wondering what's on this picture. Actually, this is a number of GitHub organizations that Intel used to manage, and you see some blue ones and some gray ones because we took down after the huge inventory a couple of years ago some outdated stuff, but this is organizations that in summary contain around 5,000 open source repos that are managed somehow or co-managed by Intel. So that's a huge history actually. We are doing open source for a little while, like 20 years already, contributing to these efforts. And also we are participating in these foundations and organizations. I'm personally part of some OpenSSF working groups that is a sub-organization under Linux Foundation that do the great stuff around open source security. But today, I mostly will reveal our experience as an open source consumer, because Intel is a huge organization, and obviously we do a lot of software on our own. So that, of course, we're going to make sure that we do it securely, we consume it securely, and then deliver the flawless software to our customers, either to open source or as a proprietary software. All right. So we are here in the Java kind of conference, and that makes me wonder why a couple of years ago everybody started to talk about Java again, especially in security world, from security perspective. Well, I think the first and obvious answer because of some nice features that we have for Java language, and this is really cool, especially in the lieu of just everybody in the governments in the US, for example, they're talking about switching over from languages like C++ to memory-safe languages, right? And obviously Java has some other cool security-native features that is really great. Compiler time checks, for example, bytecode runtime checking, namespace, some kind of isolation, memory-safe, which is arguable. We still have seen some attacks around this, but anyway, this is a cool set of features. But what happens in 2021? Any ideas? Exactly. Log4j, this is not really, of course, this is a Java-related thing, but that's, I think, made a huge wake-up for everybody and highlights the issues with the supply chain and the vulnerabilities in open source software that could cause some really dangerous and unpredictable consequences, and that's the whole nightmare that happens around the world. All the vendors urgently used to patch their servers, their software. Yes, that was a big nightmare, but that was a good side effect also because, again, it highlighted the problem and it brought a little bit attention from everybody to how we're going to solve this problem. I have maybe a silly question, but does anybody use open source software in production in some kind of like dependencies? Everybody, and you, Alex, you didn't raise your hands. Probably you don't know about that. So, but yes, everybody. A little bit of statistics. This is 1.2 billion vulnerable dependencies are downloaded each month. Of course, some of them are taken down, sorry. But this is happening every day. The other piece of statistics that nearly 90% of codebases contains open source more than 4 years out of date. It is arguable that it's necessarily vulnerable, but if nobody look at that for a long time, probably it is. But what we're going to do with that? We are going to all die. Probably yes, but not today, obviously. And a lot of different things are happening around securing open source, and that's why the first suggestion is to understand where the risk is for you specifically. It could be a little bit small on the slides, but I'm going to give away all the slides and links so that you can click the links and follow all the tips there. So this is good risk list, top 10 open source software, open security risks. It's kind of generic list, but it could make you think what to focus on first, dependent on your way, how you consume libraries, what languages, what frameworks do you use, what's really important for you. For example, I don't know whether you're doing your in-house deployment or you are selling your software and services to the external users. So it's really important to focus on the risks first that matter to you, because especially if you just start your journey to secure open source development in general, it's really impossible to tackle everything at one time. The second generic advice is apply, of course, industry best practices, but some of them work, some of them don't work, and you probably must have a look at the security supply chain consumption framework, so-called S2C2F. I think this is invented first by Microsoft, but right now it's under Linux Foundation umbrella. This is a good and concise framework, embracing all the details of the cycles and what you should do in order to take care of your open source dependencies all over the cycle. The second one is quite nice, released recently, I think in 2023, kind of December or November, Securing the Software Supply Chain, a good paper, joint paper by NSA, CISA, and ODNI. So it's definitely worth to look at. But if you have more time, just this is at glance, if you're starting and wanted to give an essence of what should be done, but worth reading another conceptual documents, let's say NIST SSDF obviously is a huge reading stuff, but it's worth to have a look at that. Other documents listed here, they're all free, of course. You can just click link and download good frameworks. Other just for the reference to follow up after, good but not necessarily focused on open source security. Of course, open source security is the little part of the overall software development lifecycle, but this also a good framework that's actually work. So diving a little bit more to the practice. So this is kind of theory stuff and prerequisites, the good materials that you can follow up a little bit later. Any guesses what's this on the picture? Wake up, guys, it's quite easy. Any dummy guesses? Good catch. This is security development lifecycle. I mean, this is like specifically made by Intel, but it's very generic. Again, nothing really kind of unusual here. It's the overall security development lifecycle, and the reason why I'm showing you here because the open source security and taking care of your dependencies, taking care of the repos when you ingest in your dependencies and making sure you clean up everything and you ship the non-vulnerable product, whether internally or externally. It's a part of the overall management lifecycle and secure development lifecycle eventually. So it couldn't be like a separate activity. So it should be included. But if we are thinking about open source security, we at Intel think it should be something like this, comprised of the, again, certain parts of the certain steps, secure sourcing, secure development, build and release part, maintaining production, and a little bit two pieces on the top and at the bottom, community engagement and SBOMs, of course, one of my favorite topics. So if you're doing good in all of these spaces, probably you're doing good in your open source security journey. And right now, today, we are going to discuss how to do it. And of course, this is a huge area and a lot of stuff happening there. That's why I will try to focus on these 4 parts. Actually, on the 3 parts, SBOM, we will touch really briefly because I believe we will have the overall talk about SBOMs later on. So, but everything else will be covered with examples and, let's say, inspired by true stories. And this is the first inspired by true stories, and this is related to secure sourcing and secure development. If you remember the title of the talk, this is a hacking and defending the open source. So obviously, during the talk, that would be the 2 parts, like hacking part, what could possibly go wrong, and defending part, what we're going to do with this. So, what could possibly go wrong with the when you're handling when you're ingesting libraries from different repos using different frameworks and etc. The kind of popular list of things. The first one is dependency confusion, and the real life example of this this npm install analytics PayPal seems to be fancy because this example, of course, it's no longer exists, but it's a real story. This is really interesting because it uses the very famous name of the company PayPal, and we have seen a lot of similar cases when malicious actors actually exploit the big names of the companies. So it's used to launch malicious script to make some requests to the domain, because I mean, if you read carefully this domain that DNS requests would be sent to, probably you spot on immediately that something is not real here. But who cares in the practice, right? We are just doing an npm install and that's it. So it's working, that's happening, nobody cares. So it's an exfiltration data case. Now, of course, this repo is deprecated, but it was a real life story. So isn't it easy to hack open source? A little bit of effort, but it isn't impossible. Typo squatting and masquerading, they're yet another popular technique. And this is example that happened, I believe, a few years ago when, or maybe 1 year ago, but this is exploitation of the LLMs AI hot topic that we have right now. So how could have I missed this AI stuff in my presentation, right? No way. So this is a Luther AI instead of a Luther AI, which is legitimate package, but this is fake LLM model that was added to Hugging Face, and all the data scientists that use these nice plugins, nice models from this marketplace, they have been poisoned, right, because of the ingesting this stuff. And this is happening in the real life again. Trojan injection and protestware. This is an interesting category as well. How many of us using Dependabot? Not everybody, I'm surprised, but still a decent amount of folks. I think maybe a third of the audience, and that's good. Dependabot is the useful built-in tool into the GitHub that can show you the outdated dependencies, can show you the CVEs vulnerabilities in third parties, and it's quite handy. And it creates automatically pull requests to bump it up to the newest version, and that's it. That's very interesting. And this story actually happens also, if I'm not mistaken, last year, so quite not too far away from now. So Dependabot commits that was not done by a legitimate Dependabot, but by some user that pretended to be Dependabot with a similar kind of naming on there. And because of the some repos, they just accept Dependabot's commits by default because we trust this. So they automatically ingest or merge these pull requests that apparently contains info stealer. So again, stole the information from the repo or from your infrastructure if you allow Dependabot working there on your repos. Repo package hijacking. This is another cool story. Koa was hijacked over npm account takeover. You can say that this may be unrelated to you, probably almost all of the audience just consumer, not like doing something. But anyway, that's still the case. When somebody takes over the popular repo, popular accounts, and then kind of can do whatever they want, and you just ingest it. If without any checks afterwards, you're going to be poisoned, you're going to be done. By the way, the core is a command line parser, 9 million weekly downloads, something like this. So, of course, it's fixed right now, but it was, again, a real case scenario when how easily it could be hacked. Fancy, isn't it? I think so. So to lay down the pictures a little bit, what we should focus on at this stage when we are sourcing our dependencies, when we are doing our development using these third-party libraries. First of all, if we are having a look at this picture, developers submit maybe bad code, right, to the source. And this is compromise source control possibility. Then what's happened that with modification of the code all the way to the build system, it could be compromising build platform or compromised build platform eventually. So something could happen badly there if you don't check your environment, your infrastructure. Of course, use bad dependency. This is quite a usual case, unfortunately, that's happening frequently. And again, this is a major job by repos and by maintainers, but at the end of the day, it's your open source, not somebody else's. So you should double check. Bypass CI/CD, it's also possible, like using the shortcuts, bad commands, etc. Compromise package repository, using bad package eventually. So it's all could happen, and so many ways how to eventually hack pipeline. That's why this all DevSecOps comes to play. But again, today we're trying to look at this from open source security perspective. So don't forget to double check at all the stage, all over the way through your DevSecOps. What's good practices we can suggest to mitigate all of these risks, right? And assess repo health. This is a really good practice, and one of the tools that I personally could recommend. I'm going to reveal the whole list of tools later on, but one of the tools is OpenSSF scorecard, which now works with GitHub and GitLab, so that can show you the health of the repo that you're ingesting. And this is kind of cool because this is whole list of checks. For example, how frequently this repo handle their own CVs, how many updates it has, whether or not it has some kind of malicious runners or unhandled tokens, permissions, bad permissions, something like this. And please do this. This is quite simple. It could be done occasionally. Also, OpenSSF scorecards right now has their own visualization tool so that you can just feed it up, feed the interface up with the GitHub or GitLab link, and this is the nice picture out of there. But also, which is more important, it has their automation on board, like GitHub Actions, so you can do these checks automatically, right? And see, okay, if this repo's score is really bad and particular checks are really bad for us specifically, we're not going to ingest this repo, or we're going to wait, for example, when all of this will be fixed. The second suggestion is do all possible verifications, like checksums if it's available, signatures if it's available, using, for example, npm CI instead of npm install. Is a little typo here. So like these native things that probably ChatGPT wouldn't implement for you, so you should think and do the things properly. Proactively scan for vulnerabilities and malware. Apparently, even open source repos, they could contain some malware inside, and even just simple anti-malware scan can reveal some viruses inside it. And the thing is, it doesn't matter what exactly you're consuming, whether it's binary, like library, compiled, pre-built, or whatever, or it's an open source code. It's all could contain some malicious part in it and malicious binaries. Unfortunately, I have seen so many cases in my practices when the open source code pretended to be like a source code, apparently that contained a lot of binaries. Some of them were malicious at this time. So just don't trust and don't think, okay, it's not relevant for me. I'm just consuming some source code so that I'm not going to scan it with the binary scanners or malware scanners. So use latest and greatest and continuously update. This is maybe arguable part for us, for software developers, because using the latest not necessarily, it doesn't necessarily mean that it doesn't break my overall system, but eventually you should strive to use latest and greatest and upgrade constantly. And within my teams at Intel, we went through this pain, to be honest. And right now we are quite good with frequently updates of third parties, but before that, I personally had a huge pushback from development teams. They were saying, okay, oh well, how can we automatically update these dependencies? What if the code is broken, the overall systems will be broken? So it's all possible to include the tests and to establish eventually the cadence that could be beneficial for everybody, for developers, for a deployment team like DevOps team, and for security as well. So again, it's not necessarily you need to do your updates every second, every day, or even every month. I don't know, but finding the proper trade-off is possible for all the types of applications, at least to my practice. The next one, curate and store locally npm set registry, for example. This is a Java relevant example, but it's probably for big companies good thing to store their repo locally, but for critical dependencies, I would suggest you all think about having your own local repo for some of them, so that you can control what's happening there. You can verify continuously, even though you don't have the huge team of security researchers. At least it's an availability question, right? You always will have this repo stored locally. Some of the other useful practices, like ignore scripts, enable, of course, 2FA authentication whenever that's possible. The last one is really interesting one, why people think still linking all these kind of jars, binaries containing all of these dependencies. I don't know why this is happening, but it's too many cases when you really stuck with the unavailability of updates really quickly, because you have all of these, let's say, legacy and all of these binary files that contain their own dependencies, like indirect dependencies, and that's unstoppable chain, so that you should update everything or wait for all these vendors when they update that. So if it's necessary, that's okay, but if it's only for your convenience, I would suggest don't do that. Switching over to the tools, that is kind of 3 categories. Again, it's all will be available with the links, direct links. It's all free. Source health check, I mentioned. OpenSF scorecards already. DebsDev, a cool project by Google with the same one. And obviously, native tools like NPM, not native, but really relevant for maybe for your job. NPM Audit or NPM Doctor is a really convenient tool to be used. Don't forget to use them. For local package management, there are some tools, not necessarily Java or JavaScript relevant, but still in place. And for the dependencies, I mentioned Dependabot, a cool feature. Don't get me wrong. I mean, that was a bad example of blindly using something that contains Dependabot in the header or in the name of the contributor. But this is a cool stuff. Renovated boat that I personally like because of the fastest and really interesting, great integration into CI/CD pipeline, no matter of what tools are you using, Actions, Jenkins, whatever. OSV scanner and other scanners for Python specifically. If we have some Python developers here, this PyUp, they're really cool, great, Python native tool to bump up dependencies. All right, what do you think? What's on the picture? So another question. Any guesses? What's on the picture? Closer. All right, this is the kind of the first and second, I believe, or one of the first answers from the Google page, like images depicting S-bombs, software bills of materials. This is cool stuff because right now, for those who are not familiar, that is basically means having inventory of all the dependencies that you have in the formats. Currently, there are two main or most popular formats: Cyclone DX and OSPDX. So that allows you to do this inventory management. The problem is that, of course, it's not so easy to understand all of these connections because of different reasons. But kind of having in mind or documented what you actually use and what's underneath, it's really good, right? It's all about inventory. It's all about understanding what you actually have in order to understand what you're going to do with this. Right, but understanding what you have, the first question. Why S-bombs are really useful? This is a case study, again, inspired by a true story. Vulnerability has been disclosed in the popular dependency you explicitly use. I mean, this happening every time. It was log4j, it was zlib later on. Right now it's glibc, which is a nightmare of all the Linux distributions currently. Right now it's happening. So the story is pretty much simple. So this is a high-profile vulnerability, and you have the, like a company or a security person, you have the internal or external customers ask, we are affected or not? So I have seen in the news that log4j is happening. I'm affected using your software. So this is, I think, simple question, right? Do we have simple answer? So probably we are going to ask ourselves the question, how much time do I need to assess first and then mitigate if I am affected? So, and with S-bombs, actually your timeline is significantly improved, because if you understand all your dependencies, what's happening, what exact versions are you using of these high-profile, out of these high-profile cases, right? Executes third-party dependency catalog, S-bomb or whatever, right? Ingest risk assessment details. If your vendor have one, or the open source repo has one, implements laser focus, kind of, I don't know, take down only this service which is affected, or update it, or whatever actions you would prefer to take. But having the inventory handy actually helps everybody, both vendors and customers and everybody who is developing their software. But this is a good question. That sounds like cool. I mean, in the seconds, I'm gonna find all my dependencies and gonna understand all my vulnerabilities out there. So now all the problems are solved, and as a security champion or developer, I'm not gonna to. So finally, I can have a rest, right? So you probably would be suspicious, right? It's not that simple, unfortunately. And this is relatively new S-bomb quality report that's been done at the end of 2023 by Purdue University and ChainGuard. And they analyzed some scan data, some kind of open information, something like this, using some scans and whatever, and I would highlight some of the numbers there. So they, again, analyzed S-bombs, so information about dependencies, scanning the packages, package systems, etc. And you can see how much quality currently they have, right, S-bomb files provided. Not even in each single SBOM file you can find the information that is required by SBOM specification or by SBOM NTA requirement that stands for the kind of minimal requirements for SBOMs. What should be inside, right? Tool creation, package version, package ID, package licenses. I'm not talking about the inconsistency between package names, for example. If you are ingesting the same dependency via different sources, for example, it's completely a mess, right? Because you have the different names with these dashes, slashes, like everything, right? So, but not even all SBOMs contain this necessary information, unfortunately, even package ID and package versions. So the quality of SBOMs is generally not as high as we could expect, but it doesn't excuse us from starting using it, providing feedback to the vendors, providing feedback to the community, and it's actually useful in practice somehow, but unfortunately it's not fully automatable right now because of the quality, but it's good stuff to think right away. So for SBOMs, to summarize some practices, some good practices, what I would suggest to do with this SBOMs is 3 reasons why we are doing SBOMs, we're ingesting and having these SBOMs, know what we consume, enable at the end of the day automation, because the idea behind SBOMs is pretty good, right? Having all these JSON files within conformant to specifications so that I can feed up whatever systems that I have internally with these files and do this analysis fast. So again, this is in theory, and I think we will be there eventually. So, and that's the third reason, accountability, to understand what exactly I'm consuming from where, why I'm doing that, and what I'm going to do with this when I build my own applications. Don't stick to the format, just pull something. Again, right now it's a little bit mess. Just pull something, analyze something, validate SBOMs, provenance, signatures, if that is available. For some vendors, for some sources, it's available already. I would suggest to create your own SBOMs. That's quite cool, and don't underestimate these parts of the recommendation, because you can ask me, okay, why do I need to create my own SBOMs inside the organization if I don't ship my software, for example, to US governments? Because it's right now the requirements. If you're shipping to the government bodies in the US, so you should provide the SBOMs with the software upon request. But if you don't do that, it's a real good stuff for you to understand, kind of to compare what you had with SBOMs ingested with the third-party vendors and open source vendors, and what eventually you have building your own software. So, and playing around these two parts, you can understand even better what's happening in between and how your overall even infrastructure and dependency management process could be improved. Leverage ingesting so-called CSAF and VEX. This stands for VEX stands for Vulnerability Exchange format, right? And CSAF is kind of a little bit extension of that, like specification for sharing the disclosure information. Basically, information is about vulnerabilities, CVEs, right? And this information is available by some vendors already, by some open source already, so it's intended to be machine readable as well. So you can understand that, and as I exemplified a little bit earlier, to understand exactly where the problem is when you have this disclosed high-profile vulnerability and pretend the bright words when we have all the information in the JSON that you can consume, then feed up with your, I don't know, scanners or whatever tools you use internally, and then it automatically even deploys the mitigations where they have to be deployed. I think it sounds like a magic, but I believe we will be there eventually. And tools for SBOM generation. If you decide to generate your own SBOMs, It's all available again in open source, a lot of tools. Microsoft has their own one, SPDX community has their own one, GitHub has the built-in feature to generate SBOMs in both formats, scanners like open source and of course commercial scanners as well, but this they're all open source. The nice tool like Parlay, for example, like a proof of concept but free tool by Snyk to enrich your SBOMs with additional information. And I think it's happening for a few years already. There are some SBOM verification tools that came up, like validation, for example, OpenSF SBOM scorecard, which shows you the quality of the SBOM. You remember my example about the research, right? That's okay. Some of the SBOMs even don't contain the ID and package information, something like this. So these verification tools can show you the health of it. Okay, we're doing good in time, I think. Build and release. So runners. Yes, switching over from ingesting and developing, it was really the main part of the story, because pretty much everything should be handled at this stage, and if your good's there, you like shift and left, right? So then you wouldn't need to handle it at the later stages of your development lifecycle, but still something bad could happen, and you should double check at build and release stage as well. So the one example, again, inspired by true story runners, this kind of actions, CI/CD jobs, right, that we call them. Both tools, for example, GitHub and GitLab, they provide their own runners, right, from the marketplace. They're considered relatively secure, like verified, something like this, but you should be suspicious that I think you are anticipating the cool story after that. That's true. What about self-hosted runners? That is might be useful because that allows you to leverage some additional control over the hardware or operation systems, so that it's not necessarily available if you use the provided by GitHub one. So you sometimes need to use self-hosted runners, right? It's kind of valid business reason. And non-ephemeral runners and default settings. That is quite interesting, because what does that mean? Ephemeral runners perform one job at one time, the simple explanation, right? They do their own job they're intended to do, and then wipe it away. So unregistered, that's it. But in fact, non-ephemeral runners, of course, still exist, and they were not stuck to the one job. And it turned out, again, that's inspired by a true story. In this example, it turned out that any contributor, even if the contributor to documentation, right, to, I don't know, README file or another part of the documentation with previous PR approved, can execute these runners, for example, later on, because right now it is the trusted contributor have done this dummy PR to documentation. Later on, nobody cares. Unfortunately, if you don't care, they can run these non-ephemeral runners and do some malicious stuff. And it turned out remote code execution is possible in this case. So because this malicious contributor can leverage these non-ephemeral self-hosted runners to escape to your infrastructure, for example, or steal your data, or kind of interact with command and control server, something like this. That's quite cool, isn't it? This is a little bit of example how it was a kind of inspired by true story, drawing a picture. It would be a developer that that uses REST API, for example, to this again quite a generic use case, right? To SaaS service like GitHub, commit to Git repository, and GitHub Actions connection also need to be in place, right, to your internal network. And There are good self-hosted runners, nothing bad with that, but an attacker can run the malicious workflow and can check out the attacker's code and put the malicious runner to your infrastructure and then eventually exfiltrate the data to the command and control server or let this server to do some lateral movement, for example, inside your network later on. So this is quite interesting, and the practices are in place, like isolate your internal infrastructure. It sounds like a pretty much generic info security stuff, but I have been seeing so much time this when we are doing our pipelines, our development pipelines, deployments, and etc. We don't sometimes we don't care about just the good InfoSec practices like these hardened access, token management, Git permissions, code owners, prevents, of course, runners from approving pull requests. This is happening in the real world. I mean, I'm not kidding you. So some runners still approve the pull requests. I mean, blindly, it's kind of nightmare. Scan binaries against CVs, of course, check infrastructure, scripts, and etc. So that's a list of the tools that are useful for implementing these practices. Again, scorecards, some of the secret scanning tools that are sometimes embedded to the tools that you have been using building your or doing your DevOps. But this is all open source. This is all free. And for example, I would really endorse the CV bin tool. This is an Intel built open source tool for scanning binaries for CVs. I'm not sure how much of you know any CV binary scanner that is free. So it's not too much, to be honest. So this is one of the example. Salsa, I briefly mentioned that. We are almost out of time, but I think it's worth to mention this Salsa part, right? It stands for Supply Chain Levels for Software Architects. This is specifications concept, but eventually a standard that, in the nutshell, in the few words, allows you to do reproducible builds to make sure your build system logs everything that's happening with your builds. That's they call provenance, so-called the meta information. What's inside the builds, when it will build by whom, by what system, all the dependencies, and etc. So that it could be verified later on in the cycle. And the idea is, no matter when you eventually will be using this binary, accompanied by provenance, you always can verify that this is not malicious binary. This is legitimate one. So in some of the tools for generating this Salsa provenance, for verification Salsa provenance, again, this is not, unfortunately, that everybody is doing right now, but if you go into the site and Google a little bit, you can find there are more and more package managers, and they're kind of famous package managers, famous frameworks. They are following concepts of reproducible builds. Yes, this is what I've been talking about, reproducible builds. If you can follow the link, you can find the tools and projects that right now are participating in this reproducible build stuff, which is quite a good. Okay, we are wrapping up, and how to secure your open source. Quite a recap of what we have been talking about. Be on top of hacking, understand how it works. I think the hacking part is very important, even though you're not pretending to be a hacker, but to understand how, what could possibly go wrong is really important. Trust, of course, don't trust, right? But verify, always. Don't trust and verify. So it's on each stage of your cycle. Do what majority does. This is very important because so many times I've seen, okay, we're going to invent our own kind of build system, our own approach, because we are true developers, true DevOpsers, but do what majority does. Don't try to reinvent the wheel. a lot of good practices are available. Automate and oversee pipelines. This is really important. Like oversee pipelines, understand what's happening there. It's really, really important. I think, oh, right, this is the Intel Product Security Report. This is the old one, but stay tuned. In about a month, we are going to reveal our own one, 2023, for the previous year. And this is how we do our product security practices publicly with a cool video, cool statistics, and etc. You can follow this. I think I'm running out of time, but I'm going to do a quick poll. Do you want to see some bonus today or not? 1 minute. This is a bonus in the preparation to the conference. I did a quick research, and how much of you are familiar with OpenSSH? Yeah, for sure, everybody. And this is just a few days ago. I double-checked how many vulnerabilities currently OpenSSH had, like 100 or something. Of course, they're almost all fixed, but it's just in general CV records. So then, of course, we have been seeing these headlines like OpenSSH vulnerability, actively exploited, blah, blah, blah. It's basically happens in 2023, but this is a generic story about the famous open source tools and libraries. And then I was thinking why I don't explore some stuff that's happening around the cities of Stockholm. And I used one of the popular tool that allows you to search the internet and see what's open to the internet for the given location. And the latest version of the OpenSSH, if I'm not mistaken, is 9. And I crafted the special request and was able to see how much hosts face into the internet right now in the Stockholm with the outdated version of with OpenSSH. What is it? 150,000 of them. Does that mean they're all vulnerable? I don't know. Probably there are some patches applied, but it's still good food for your thoughts eventually. So it's your open source. Take care of it. It's our responsibility. Thank you, guys.
Okay, if you have any questions, come down and catch Roman in the hall.
Yeah, thank you.